Okay, looking at Module 2, Section 4 for Algebra 2, we're talking all about systems of three equations and how to solve those. So if you look at this first statement here with me, it says, so far we have solved systems of two equations with two variables. We're now going to be solving systems of three equations with three variables. And the general rule of thumb is, if you have the same number of variables as you do equations, that it's solvable. So with three equations and three variables, we can definitely solve this, but it's going to take a lot more algebra than the system of two equations. If we look at how we might solve this, I mentioned we're using some algebra. That's because we have three variables. We have x, y, and z. And we can't graph this on our 2D graphing calculators like Desmos or a TI calculator. You actually need a 3D calculator, which we don't have, to solve these, graphically at least. So what we're going to do is a combination of elimination and substitution. So that is a review of Section 2. We're going to use the skills from Section 2 to solve these problems. And I broke this down, and you're going to see me label these steps pretty often as three simple steps here. Step 1, eliminate one variable from two pairs of equations. Step 2, solve the system of two equations that you have remaining. And step 3, substitute the two known values back into an original equation to find the third value. So it's really important on these, I can't say this enough, you've got to keep yourself organized. So I'm going to try my best to stay organized. And I recommend as you're solving these, you try to find a way that fits you best to see what you're doing and stay organized. So right now, it says let's solve the system of three equations here. And what I normally do when I solve these is I label these as equations 1, 2, and 3. Just so I can refer to them later as such. Let's start with step 1. I'm actually going to type this because you've all seen my handwriting on here. It's not the greatest. So step 1, we're going to eliminate one variable from two pairs of equations. That means we need to find two different equations and eliminate the same variable. So let me put that underlined in green. That's step 1. If I'm looking at these three equations, I want to try to eliminate one of these variables. And it appears to me that y's might be the way to go, these y's. So I'm going to look at, let me erase what I just did, equation 1 and 2 first. Let me look at equation 1 and 2 first. Equation 1 is 3x minus 2y plus 4z equals 35. Equation 2, negative 4x plus y minus 5z equals negative 36. Use elimination to multiply one of these equations. We're going to get rid of those y's. So let me look at this second one. And if I want this to be positive 2y in the second equation, I'm going to multiply all by 2. So let's copy over what we have. Well, the top one we didn't change. The one on the bottom we multiplied by 2 in order to eliminate the y's. So I said I multiplied it by 2, but I didn't write that. Negative 4 times 2 is negative 8. 2y, negative 5 times 2 is negative 10z. And then negative 36 times 2, negative 72. With elimination, remember you always add these. So I'm going to add these two up. Put an addition sign there. 3x plus a negative 8x, negative 5x. We do have our elimination. 4 plus negative 10 is negative 6z. And then 35 plus negative 72, negative 37. Okay, So we did half of step 1. It says eliminate one variable from 2 pairs of equations. We did it from 1 pair of equations. Now we have to eliminate y's in a different pair of equations. So let me scoot this down a little bit. And let's look at equations 2 and 3 this time. Now I'm going to choose 2 and 3 because I can just multiply equation 2 by a certain number to cancel those y's. So let me write down 2 let me write down 3 and if I multiply equation number 2 by 3, it'll cancel those y's. So I have negative 12x plus 3y minus 15z equals negative 108. Second equation stayed the same. 5x minus 3y plus 3z equals 31. And then elimination says we add these. Negative 12 and 5 is negative 7x. Again, eliminated the y's because we eliminated them in the first part. Next is minus 12z equals 108, and 31 gives you negative 77. Step 1 is done. Okay, let's go back up and look at what step 2 says. Step 2 says solve the system of 2 equations. We came up with 2 brand new equations with 2 variables. And remember earlier I said if we have the same number of variables as we do equations, we can always solve it. So a system of 2 equations and 2 variables is step number 2. I'm going to go back down and I'm going to type that in right here. Step 2. Solve the system of 2 equations. And that's the new ones that we just starred. So I'm going to put in parentheses, starred. Okay, so these 2 equations, negative 5x minus 6z equals negative 37. Negative 7x minus 12z equals negative 77. Well, it looks like the easiest method here, if we stick with elimination, is to multiply this first equation by negative 2. If I multiply by negative 2, those z's are going to cancel out with 12 and negative 12. So I have 10x plus 12z equals 74. The next one stays the same. Negative 7x minus 12z equals negative 77. Elimination says I'm adding these 2 equations straight down. 10 and negative 7 gives me 3x. Our z's cancel. That equals negative 3. So when I solve for x by dividing 3 from both sides, x equals negative 1. This is good. We found a value. X equals negative 1. But we did not completely solve the system yet. We can plug x back in to one of these equations and find z. So let's do that. I'm going to choose, let me highlight this first equation right here. I'm going to choose this one because it has smaller numbers. This guy right here. I'll do that off to the side. I'm going to plug negative 1. Let me put that up here. Into negative 5 times x. We said x is negative 1. Minus 6 times z equals negative 37. Well, negative 5 times negative 1 is positive 5. I'm going to go ahead and subtract the 5. Negative 6z equals negative 42. Divide negative 6. And z is 7. We now have 2 of the 3 variables solved for. That brings us up to step 3. So if you take a look back, step 3 said, substitute the 2 known values into an original equation to find the third value. So now we're going to have to go back to our original question and choose one of the equations originally to plug these into. So let me take you back. We need to choose one of these 3. It's not going to matter which one. As long as our math is good, it does not matter. I'll just go ahead and choose equation 1 since they all look about the same complexity. I'm going to choose equation 1 and plug this in. So with equation 1, 3, we said x is negative 1, minus 2 times y, plus 4, we said z is 7. Well, 3 and negative 1 gives you negative 3. 4 and 7 gives you 28. I'm going to combine negative 3 and 28. And solve this from here. Subtract 25. Divide negative 2. And you get y equals negative 5. So putting it all together now, we would put our answers in an ordered pair before. Well, since we have 3 answers, let's put it into an ordered triple. That means you put it into, in parentheses, an x, a y, and z. And that's our answer. Okay, let's try the next one. Looking at these equations, I should probably number them again, 1, 2, and 3. And we're going to go back to step 1. Eliminate one variable from 2 pairs of equations. So we have to pick 2 pairs, doesn't matter which, and eliminate a variable. Last time we did the y's. Well, looking at this, it seems like the x's might be easier because I have a negative x that I can work with and only multiply that to get to negative 4 and negative 6 eventually. So I'm going to stick with, to start, equations 1 and 2. Let me copy those. Whoops. There's 1. And there's 2. Well, to eliminate the x's this time, let's take the second equation by 4. First one stays the same, 4x minus 3y plus 6z equals 18. Second one multiplied by 4 gives you negative 4x plus 20y plus 16z. 48 times 4 is 192. Elimination says add those together, and we got our elimination of the x's. Negative 3y plus 20y gives us 17y. 6 and 16 plus 22z. 18 and 192 equals 210. Let's try, because it looks like we can multiply equation 2 again to get what we want. Let's try 2 and 3. we have to eliminate the same variable. So if we eliminated x in the first one, we eliminate x in the second set. So copy those equations down. That means eliminating x, I multiply equation 2 by 6. So when I do that, negative 6x plus 30y plus 24z equals 48 and 6 is 288. Second one stays the same. Again, elimination. So we're adding these together. Our x's eliminate. We get 28y plus 29z equals 288. So then step 2, remember, says solve the system of 2 equations. We just created a brand new system of 2 equations. I'll go ahead and star them like I did last time. It's this one and this one. So in step 2, I'm going to copy those 2 equations down. 17y plus 22z equals 210. 28y plus 29z equals 288. And we're going to solve these two. I'm going to go ahead and use elimination again to solve these. Our biggest issue is going to be we can't multiply just one of these equations to eliminate one of the variables. We're going to have to multiply both equations. So what I'm thinking is if I multiply to cancel out these y's right here, if I multiply the top one by 28 and the bottom one by negative 17, those should be the same number, but just opposite. Let me show you what I mean. I'm going to multiply this top one by 28. If I do that, that's 476y plus 616z equals 5,880. Now if I multiply this second equation by negative 17, I should get the same value for y, just opposite sign. So I get negative 476y plus 493z. That's actually a minus because we're multiplying it by a negative. So let me change that. Equals another negative 4,896. Let's add these together. We got our elimination of the y's. The z's give me 123. And that equals 984. Divide by 123. Z is 8. From there, in the same system of equations on step 2, I can find y. I'm going to choose the first equation to work with. It seems like it's slightly smaller numbers. It really doesn't matter, but let's do 17y plus 22 times 8 equals 210. 22 times 8 gives me 176. So let's subtract that over. 17y equals 34. That's going to work out nicely when we divide 17 because y is 2. That leads us to step 3. We've got 2 variables. We just need to substitute the 2 known values into an original equation to find that third variable. So let me jot that step 3 down here. Again, I'm trying to stay as organized as possible. Substitute the two known values into an original equation to find the third value. I know y is 2 and z is 8. Let's go back for a second to an original equation. All the way up here. So if I'm looking to substitute one of these in, again, it doesn't matter which one. I'll just go ahead and choose the second one because we just have a negative 1x. Might be easier to solve for. Let me go back down. And I'm going to say negative x plus 5 times 2, because y is 2, plus 4 times 8, we know z is 8, that equals 48. Negative x plus 10 plus 32 equals 48. 10 and 32 give me 42, so I have negative x plus 42 equals 48. Almost there. Subtract the 42. Negative x equals 6. That means x equals negative 6. We've got our three values, so I'm just going to write it as an ordered triple. Negative 6, comma 2, comma 8. Again, x, then y, then z. And that's our value. Okay, last example here. Only 3 of these just because they take so long to do the systems of 3 equations. So on our last, let's go ahead and number them equations 1, 2, and 3 again, and start with step 1. Again, I'm not going to write it out, but step 1 is eliminate one variable from 2 pairs of equations. Eliminate one variable from 2 pairs of equations. So, if I'm looking at eliminating one variable, it doesn't look like we have any easy options here. The smallest numbers are the x's. Tends to be the easiest way to go. So let's do x's for elimination. So step 1, we're going to eliminate the x's from 2 different pairs. Maybe we can do 1 and 2 first. So let me rewrite equation 1 and 2. Well, I want to cancel those x's. So let's multiply the first one to get to negative 30. So that means times negative 6. And this bottom one, so x can get to positive 30. That means times 5. So we've got negative 30x minus 24y plus 30z, and that equals 60. The next one, 30x plus 75y plus 60z equals 120. Add these together, eliminates the x, 24 or negative 24 and 75 gives you 51, y, 30 and 60 gives you 90, z, and that gives you 180. We've got our first set. Maybe we can try 2 and 3 next. We're going to have to multiply both equations again, but I'm going to copy down equation 2, and then I'm going to copy down equation 3 and do elimination with those. So it looks like the first one we might want to multiply by 2, and this one want to multiply by 3. That'll get our x's to 12 and negative 12. That seems to be the smallest number to get to. So 6 and 2 gives us 12, 15 and 2, 30, 12 and 2, 24z, and then equals 48. Multiplying it all by 3, we've got negative 12, negative 30, negative 24, whoops, z, and then negative 48. Elimination says add these. So when we add these, the x's cancel, the y's cancel, the z's cancel, and 48's cancel. So we get 0 equals 0. What does that mean? Well, if we can remember from solving by substitution or elimination, I'll make a little note here. Whenever you get a true statement, like 0 equals 0, for example, then there are infinitely many solutions. So we had all of our variables canceled. Maybe I should say that as well. Our variables canceled. And then, whenever I get a statement that, in this case, is 0 equals 0, there are, I should say, then, infinitely many solutions. So that's our answer.